So let's take a look at implicit differentiation. So when you did explicit differentiation, you might have had something like y equals x cubed. So then when you derive this function, y prime, or dy dx, would equal 3x squared. In implicit, you might have x and y on the same side. So you might have x times y equals 4, and then you would have to derive both sides. And keep in mind that every time you derive y, so let's say we're trying to derive y, the derivative of y is just y prime. So every time you derive y, you have to multiply by y prime. And let's say we're trying to take the derivative of 6y cubed. First you would take the derivative of the outside function and then multiply by the derivative of the inside function, sort of like the chain rule. So we'd bring the 3 down and subtract it by 1. So derivative of 6y cubed would be 18y squared, and then every time you derive y, you have to multiply by y prime. So we get 18y squared y prime. And y prime and dy dx are the exact same thing, so you can change those two depending on which one you like to use. So for number 1, let's say we have to find the derivative of x times y plus 2x plus 3y equals 1. So let's just start with x times y. Notice how there are two functions being multiplied by each other. So we need to use the product rule. So we can say the derivative of x is just 1. So the derivative of the first function multiplied by the second function, so y, plus the derivative of the second function. And remember, the derivative of the second function, y, is just y prime, times the first function, which is x. And now we can move on to the derivative of 2x. Derivative of 2x is just 2, plus the derivative of 3y. And remember, the derivative of 3y is 3 times y prime, because the derivative of y is y prime. And then we can set that equal to the derivative of 1, and the derivative of a constant is always going to be 0. So if I were to simplify this, 1 times y is y, plus xy prime, since those two are being multiplied by each other, and then we get plus 2, and then plus 3 times y prime, which is 3y prime, equals 0. And our goal in implicit differentiation is to isolate y prime and find out what that is equal to. So if I were to bring the 2 over to the other side, we would get y plus xy prime plus 3y prime equals 0 minus 2, which is negative 2. And then I can also subtract the y over to the other side. So we get xy prime plus 3y prime equals negative 2 minus y. And now what I can do with these y primes is I can factor them out. So I get y prime times x plus 3 equals negative 2 minus y. And then finally, the last thing I can do is divide the x plus 3 to the other side. And so y prime, or dy dx, remember you can use both of them interchangeably, equals negative 2 minus y over x plus 3. Now for number 2, we have to find the derivative of y squared equals x over x plus 1. And so first we can start with the derivative of y squared. So once again, we can use the power rule. So the derivative of y squared will be 2y to the first, or 2y. And every time we differentiate y, we have to multiply by dy dx, or y prime. And that will equal the derivative of x over x plus 1. So notice how x is being divided by x plus 1, so we have to use the quotient rule. So we take the bottom function, x plus 1, and we multiply by the derivative of the top function. And the derivative of x is just 1. Minus the top function times the derivative of the bottom function, and the derivative of x plus 1 is just 1. all over the bottom function squared. So x plus 1 squared. Now if I were to simplify both sides of the equation, 2y times y prime is 2y y prime. X plus 1 times 1 is just x plus 1, minus x times 1, which is x, over x plus 1 squared. And almost always it's a better idea to just leave the denominator alone and not FOIL it. So when I can simplify even further, 2y y prime equals, the x's will cancel, and we're left with 1 on the top over x plus 1 squared. And then since we have to find what dy dx equals, or y prime, we have to isolate it. So we get y prime equals 1 over x plus 1 squared. And if I'm multiplying by 2y here, I got to divide by 2y. And dividing by 2y is the same thing as multiplying by the reciprocal. So multiply by 1 over 2y. And so the final answer, y prime, or dy dx, is going to be equal to 1 over 2y times x plus 1 squared.